Okay, welcome to note set M01. So this is, I number them separately for our Matlab notes just to keep them straight. That allows me to kind of insert these wherever I need them into the flow of other note sets. So this is going to give us an introduction to Matlab. So there's in the syllabus, you see that we had a optional textbook on Matlab. So this is not really covered in any specific location in that textbook, but from this point onward, for M02 and so forth, I'll give you a rough idea as to where to look in the textbook. So. Matlab is a programming language, but it's unlike some other languages that you might be familiar with. This is a graphic from this website down here, and it just kind of shows kind of the range of different types of programming environments. So you might be familiar with C or C++. And that's what would be considered like a high or middle level language. When you write it, you have to compile that for a specific target application or machine, and then you get an executable that you run. So there are two different things. There's the part that you've written, and then something that you get from an executable. And as we go further down this line, we get to things like assembly language and machine code. Those are written in more of a native set of instructions for a specific microprocessor, all the way down to binary code. So if you write in assembly language or machine code, those get compiled into an actual set of binary commands that are suitable for reading by the hardware. They tell the hardware, the actual processor, what to do. So when you write a program in C and you compile it, it probably gets, I don't really know how these things work, but in essence, it gets converted into machine code, which would then get converted into binary code. Essentially, I think in reality it just goes directly to a binary code. But you can think of it as a two-step process. And then there's other programming languages such as Python and Java and so forth. That are more like what are called scripting languages, and they're not compiled, they're interpreted. So what you write is actually what the computer operates with, or at least the program in which you are writing the software will actually interpret that. And so where does Matlab fit in? Well, Matlab is up here in this scripting and interpreted language. Although recently it has added some compiling context to it. But the way that we'll be talking about using Matlab is you basically write almost in a text file a series of commands that are commands in the Matlab language, and then you present that series of commands to the Matlab environment. Oh, there's that thing again. Don't show this message again. All right. You present this to the Matlab program, and it runs it. It interprets it and tells the computer to do these things. And every time you tell it to run these commands, it's basically going through and interpreting what those commands mean and telling the particular computer you're on to do those things. So in that sense, you may be familiar with using C language to write some commands, and then you compile it into an executable, and then that executable becomes like a program that you install on some other computer, whether or not they have a C compiler on that computer or not. Well, with Matlab, in order for you to run, quote unquote, the MATLAB program, you need to have the MATLAB application installed on your computer. Although I did just say that MATLAB now has the feature where you can take your MATLAB code and compile it into a portable executable. And we're not really going to talk about that. So in some sense, MATLAB is really nothing more than a glorified calculator, but one that you can then program and allow that calculator to automatically follow a series of commands rather than having to type them in. So we'll talk about both of those aspects of MATLAB. So where does MATLAB come from? Well, Matlab stands for Matrix Laboratory, so it's the MAT from Matrix and LAB from Laboratory. So it makes sense that we're talking about MATLAB in the context of a linear algebra course, because that's really where its origins lie. So if you go back, if you go to this link here, there's a nice little video that features Cleve Moeller, who is the founder of MATLAB, talking about how he got to where he created MATLAB. And it all started with his academic career working on a PhD and then doing research in the field of numerical linear algebra, working out the issues of how do we get computers to compute inverses and solve systems of equations accurately and efficiently. So it's pretty interesting. If all you're interested in is getting the grade for the course, don't bother. In fact, it's a poor approach in my opinion. But if you're interested in becoming a good engineer and kind of seeing what drives people to do what they do, interesting video. So you really should check it out. And just one more moment of rant. So if you are that student who's saying, I just want the grades, I'm going to caution you of having that approach for your courses, because you may not think that the stuff that you're learning is going to be that useful to you in the real world. But I've been out there, and these are the things that people do every day. And in fact, MATLAB is a very marketable skill. So the more you know about it, not just from a textbook point of view, but if you go into an interview and you can talk about, having learned a little bit about what motivated the origins of MATLAB, you'll come across as somebody who is a good hire. And, again, I hate to motivate you just to get the job. You should just be motivated because, you're interested in doing engineering, and this is the stuff that will illuminate what you need to do and how you need to do it. So MATLAB was originally grew out of these early research developments of how to get computers to efficiently and accurately do matrix computations, but it was quickly adopted by people in the electrical engineering field, and in particular in the control engineering field, and also signal processing. And so people quickly realized that they no longer had to sweat over writing their own C programs, or for that matter back then probably Fortran programs, to do all the computational stuff, because there was this new thing, MATLAB, that had a lot of that already built in. And since linear algebra was kind of at the root of modern control system engineering, as well as modern signal processing engineering and communication systems engineering, all of the stuff that was in MATLAB was extremely useful to these people. And so it became very popular and adopted very quickly and has just spread tremendously. And like I said, knowing MATLAB is a very marketable skill in almost every area of engineering. So, excuse me, what are we talking about when we talk about MATLAB? Well, it's a high-level language, so that means you're not writing in the native machine-level code or ones and zeros, but it's also interactive. So you don't necessarily have to write a program. You can use it as just a glorified calculator that has a lot more capabilities than what you have in your TI-89 or whatever it is that you have. But it also can be used for writing programs, not for the purpose of making an application that goes on some device, but a program that is suited for exploring and visualizing how math and engineering solutions behave. So we can use it to analyze the data that we have. We can use it to develop our algorithms. We can use it to model the physical real world and simulate how the physical real world might actually work. So before I became a professor, I worked for 8 years in industry, and my job was to develop signal processing algorithms. So I sat all day long writing Matlab code to try to demonstrate how certain mathematical algorithms would work on certain sets of signal data. And I was trying to demonstrate how they would perform and how they would behave. And then once I finished writing those MATLAB programs, I would turn those over to the actual software team, and they would turn it into whatever language was necessary. So probably like C or C++. And then I would also, on the basis of what MATLAB told me or demonstrated, would work with the hardware designers to figure out what kind of hardware we would need to actually implement a system to perform this particular algorithm. So MATLAB never ended up on the final platform or in the final system, but it was crucial for developing the ideas that ultimately went on to these aircraft. I worked for Lockheed Martin, and our systems would go on various aircraft, and so MATLAB was not on those aircraft, but it was underneath the development of that. And so it has built-in programs or functions that do all sorts of linear algebra stuff, statistics stuff, Fourier analysis, which you'll learn later when you study higher level signal processing stuff in the ECE program, filtering, optimization. Hey, look at this, solving ordinary differential equations. So you do kind of need to know how to solve them by hand so that you understand their behavior, but solving real world ones by hand are going to be hard. And then there's some really powerful plotting and graphics routines in MATLAB that allows you to visualize data, see how it behaves, and customizable plotting tools and so forth. And then this is something new that MATLAB has been getting into over the last 5 years or so. I say new, so I've been using MATLAB for 25 years now, and back then they didn't have this, but they now have tools that help you in the development, so improving your code quality, and then helping you publish your results to a web page or something like that. And also something that wasn't available originally, you can build graphical interfaces for the user, and that's nice if you're building a tool. So suppose you developed some analysis tools not intended to go on to end up as a C program that's put on an airplane, but it's intended to be used by other engineers for developing different types of numerical methods. You might want to include in that some sort of custom graphical interface. So that's called a graphical user interface, or a GUI. And so now you can build those. And we won't really get into those details in this course, but there's places you can go to learn how to do that. And then another new thing that has been put into MATLAB within the last 5 to 10 years or so is that it's become very easy to take your MATLAB-based algorithms and integrate them into C programs or a variety of other scenarios. So where are these things used? Where's MATLAB used? Well, electrical and computer engineers use it in signal processing, communications, networking, image processing, control systems, as I've already said. People in the test and measurement field use this, although LabVIEW is a big competitor there. People in computational finance and any kind of science where there's a lot of computation, you'll find people using MATLAB. So when you first open up MATLAB, it will give you a window that looks like this. So this is your typical personal computer, whether it's a Windows-based or a Mac. It'll pop up with this, and you can maximize this to fill your screen, which is probably a good thing to do. And so the key thing to know about is this spot right here where you see these kind of double greater than signs. That's your prompt. So this spot right here is called the command line. So we'll say that down here. And this whole thing here is called the command window, as you can see labeled there. Let me clear some of this stuff off here. And so basically you go to the command line, you click there with your mouse, and you can type something there, and it's like entering stuff into a computer. So let's see if I can get ourselves over to actual MATLAB here. Well, I got a lot of stuff going on here. Oh, nope, I'm right back to where I was. Where's my MATLAB? That's it right there. Okay, so now I'm in MATLAB, and let's see. I'm going to close a few of these other things here so we don't have them, poking around. There was an awful lot of stuff showing up there. All right, so now I'm in the MATLAB command window, and I can type anything I want. So I could say like x equals 5. So I'm assigning the variable 5. There's my favorite number again. I'm assigning the number 5 to a variable x. And when I hit enter, it echoes that back. So we can see that echoed back here. And something that you can see over here, this is called our workspace. And you can see that I now have listed there a variable called x. It tells me what the value of that is, and it tells me a couple other things about it that we'll talk about in later slides and later notes. And I can define something else. I can say y is equal to x plus 10. So now I've got another variable y, which has the value of 15 because it was x plus 10. And x happened to be 5 at that point. And so we can do all sorts of commands here, and this is what's known as working on the command line. Now, over here we have the command history. So you can see that here is this session started on 6/8 at 9:23 a.m. and you can see the 2 commands that I've done in that session. And you can see that it also retains previous sessions. So you can see that a day ago around 5 o'clock I was doing some computations there. And you can see what I was doing on previous days. And you can make this window bigger by clicking there and say maximize, and now you've got the whole command history here. And you can scroll. I'm just scrolling with my mouse. I have a little wheel on it, and you can go back a long ways to see, gee, what did I do way back then? So I'm back to March of 2016. It's now June. I'm back into December of 2015. I'm kind of curious how far this will actually go. Let's see, where am I now? See if we can get a date here. November of 2015. So I'm like 6 months ago. Now I'm back 7/15. So it's like a year back. Now I suppose it would have to do with, would depend on how much you do in each session as to how long it will maintain that. But that's kind of nice because you can say, gee, what were the commands I used last week for this? And you can scroll back and get them. And then you can actually copy them into your command window. So if we click here, you see this little partitioned thing. And if you hover over it, it will say restore command history. So if I click on that, now I'm back to the kind of default setup here. And so suppose I wanted to come back and find something that I did a couple days ago. I can highlight that, and then I can hold down Shift and use the arrows to select a number of lines. I can hit copy. I can bring that over to my command window and hit Control V and paste it in and hit enter, and it does that. So now not only do I have X and Y, but I now have my num and I have res as two variables that are defined there. So you know a little bit about the command window, you know a little bit about the command history window, you know a little bit about this workspace window. It just shows you what variables you currently have assigned. And then over here we have kind of a folder structure. So Matlab needs to know where to store things and where your programs might be located. So it will look first in your current folder. And so you can see up here it tells you the location of the current folder that it's looking at. And so we'll talk more about that. But you can see I've got a lot of different files in my current folder, which just happens to be this C users mfowler documents MATLAB folder. You can also see that I'm using a fairly old version of MATLAB. It's I think our 2016 is now available. So yours might look a little bit different than this, but it should be fairly similar. And you can scroll down here to see what else is in your current folder. And you can also use these things to navigate. So you can go up one level, you can browse your folder path. You can go forward and backward if you want. And then there's some tabs up here for things called home, and there's a bunch of things that we'll talk about later. We won't talk about all of them because obviously MATLAB is a huge program, and we could spend years teaching you all the different ins and outs of it. Our goal is to just get you up to speed so that you can do the rudiments of MATLAB, and then as you need to, explore what else there is available. So that's home. We'll be using some of these things like new script, and if we click on this, we can make a script, we can make a function, we can make a figure, and various other things. And we'll talk more about those as we need them. There is a tab here for plots. It kind of helps you make plots. I'll tell you the truth, I don't use this. I learned MATLAB before all this fancy user interface stuff. So I know how to do plots with commands, and that's what I'll be teaching you how to do, because that you can put inside functions. And then there's various apps here. If you're using the student version of MATLAB, you won't have all of these things. These are different toolboxes that are available in different functions. But we'll be sticking here at the home, and in fact, we probably won't be dealing too much with those things. So that's just a little exploration of that, and let's see if I can get back to my PowerPoint presentation. Okay, so I am back to my PowerPoint presentation. And so I've just kind of, in these yellow boxes, highlighted the things that we were just talking about here. And so you can kind of see those things. If you want a little bit more detail on that, MATLAB calls that thing the development environment. So here's a link you can go to, I think it's like a 7-minute video, and watch that if you want a little bit more detail on some of those things. Now, like I said, Matlab is a very complex programming environment. It has a lot of commands. It can do a ton of different things. And so it can be rather intimidating at first. But thankfully, they have a very nice system in place for getting help and lots of documentation. But I will warn you that the documentation is sometimes takes a fair amount of work to understand what it is that they're saying. But once you kind of get into MATLAB and you understand what they're talking about, and you've read through this a little bit, it will make a lot more sense. But at first, some of the help can just look like it's very confusing. And the reason is that the commands that MATLAB uses are very, very flexible. So there may be, 5 or 6 different ways to call a specific command name. And when you ask for help on that, it's going to give you details on all of those. So instead of just freaking out and going like, oh, I don't know what any of that is, just read it slowly and try to make sense of it. Often you only have to read the top bit of it to get the gist of how it works and get the most simple, straightforward way of using the command. So I'll illustrate what I mean by some of that. So one way that you can get documentation on a command is to type at the prompt in your command window, just type doc and then some command name. So if you know a particular command name, you can just type that there, and it will open up a separate window, and it'll have fairly comprehensive documentation. So that's really the easiest place to look, and it often has lots of examples and so forth. And so the other thing that, once you've gotten used to using a command, you may forget, like, oh, I forget exactly what the syntax is for including arguments. So we'll often have a command name, and then you need to put something in here and then end with a parenthesis. But the cool thing about MATLAB is if you start off with a command name and then put this opening parenthesis and you stop, it will actually show you, it'll pop up and show you what can go there. And then, if sometimes you don't need all of the stuff that's available in the documentation, so you can just type help command name and it'll give that to you. So let me show you this this thing popping up here and a little bit of this documentation and help. So let me see if I can navigate over to my MATLAB. So there it is. So there is a command. Let me just show you one command called clear. And you can see that what that did was it got rid of all of my variables. So all my variables are now erased. I don't have anything. So if I type X, it's going to say, hey, nothing called X. What are you talking about? So it gives you back a warning, and maybe you heard the little ding. So there's an audible warning as well as a visual warning. So let's create something else. Let's say X, and we'll see how to do this, but let's go 1 to 10. So that colon operator will create a sequence of numbers between 1 and 10 stepped in steps of 1. And we'll see that command again later in a more general form. So now I've got numbers 1 through 10, and suppose I want to add those up. So there's a command called sum. So I'm going to type sum, and then I'm going to hit parenthesis, and I'm going to wait and see how it pops up with showing the different ways of doing the syntax for that. So the simplest is to just put a variable in there. And you can click here for more help, and it'll take you someplace. So if I just put in X and end the parenthesis, that will add up the numbers 1 through 10, and it turns out to be 55. If I were to type help sum, now you can see for what seems like a simple command, it spews out an awful lot. And sometimes it's a little confusing what they're saying, but it starts off pretty straightforward. It says, S is equal to sum of x is the sum of the elements in the vector x. Now I know we haven't talked about defining vectors and so forth, but we'll get to that. So that's the simplest thing. And then it starts branching out into some other things. If this isn't a vector, but instead it's a matrix, S is a row vector with the sum over each column. Okay, nice. Then it says if you have even higher order arrays, so not a matrix, but not rows and columns, but you have rows and columns and sheets and so forth, which you can create in Matlab. It talks about sum operates along the first non-singleton dimension. Well, so what does that mean? Well, then you got to go and search out what does non-singleton dimension mean in the context of n-dimensional arrays. And then it gives some further finer points about, well, if x is floating point, it works this way, and it talks about classes and so forth. And so all of that, you might not really understand until later when we talk about double precision and single precision and classes and so forth. Then it starts in with some alternate methods of calling sum. So, up here it said that if it were a matrix, it's going to sum down the columns and give you a row as a result. Well, down here, if you put in a separate argument, dim, so the things that go inside the parentheses are called arguments. So here's the thing that we're trying to sum, and then this tells us something about how to do it. And so we could put in a number there that tells it what dimension to sum across. And look, there's an example down here that shows how that works. And then it gives a couple other special ways of calling. And so, you can say double or native, and it gives a little bit of detail about what that means. And then it also says, well, gee, you could also use the double on top of the dim. So, what I'm trying to say is that don't see all of this and go, oh my God, I can't possibly figure all that out. If you take it from the top, read down as far as you need to understand basically what it's doing, and that will probably be what you need, at least off the top, the first time you're going to be using a command. It also, the help also gives you some related things that might be useful to you. So maybe you don't want to do a sum of elements, you want to do a product of elements, and so it's suggesting that. Or you might want to do a cumulative sum. So you could click on that, or some other things. I'm not going to go into this issue of overloaded methods right now, so don't worry about that. But then way down at the bottom it says, reference page in help browser, doc_sum. So if we click on that, we get another window that opens up, and you can see that this has a lot more and maybe easier to read detail on how this works. So it pretty much gives the same information, but a little easier to read, but sometimes they give a lot more detail and a lot more examples. And since that's just in another window, we can actually just click X and close that. So now we're back in our MATLAB command window. So that's that, and let's see here. Let's zip through these things here. I think we're there. So that's how to get help and so forth. And here's a little bit more. So I just showed you how to do help sum. If you don't know the name of a command, how do you get help? Well, you can say help. And help gives you help on using help. So it will tell you how to do that. And if you just type help, it gives you a whole list of topics or categories into which MATLAB commands are grouped. Let's see if we can take a look at that. So there we go. If I just type help, so here's a whole list of things. It looks intimidating at first. I got to scroll all the way back up to the top to get into things. And so the first couple entries might just be Well, this is my current folder, and it's telling me that there's no no table in there that's telling it anything about the functions that are in there. And then I have something that I've created called, in a folder, M files, my tools. So if I build a MATLAB function that is kind of a utility tool, I dump it in there. And then everything else is MATLAB's built-in functions. And it gives you a little bit idea of what these things are. So general is just general purpose commands. So you can actually click on that and it'll take you there. Operators and special characters, programming language constructs, elementary matrices, elementary math functions. So let's just click on that, MATLAB LFun. So if we click on that, well, it should take me somewhere. I guess it's not taking me there for some reason. Not quite sure, but let's say we go help. I think we can just say LFun. Yeah, okay, so we go help LFun, which has nothing to do with Lord of the Rings. And so now it gives us a whole bunch of different commands, various trigonometric commands like sine, sine in degrees, hyperbolic sine, inverse sine, and so forth. Exponential functions and logarithmic functions. We can do things with complex numbers. We can do rounding and remainder of various types. So you can get all sorts of help on that. So if you're looking for a particular type of command, you can go to these categories and see if you can find it in there. All right, let's see if we can get back to where we were. There we are. Yeah, so we just did the help LFun. So nice I did the same example as there. Sometimes you can't quite figure out where to look. So you can do a look for command. So if you just type at the command line, look for, and then put in some term. It doesn't have to actually be the name of the command. But MATLAB will look through all of its help files and will show you where this term occurs. And I'll warn you that sometimes can take a long time for it to look through all that. And then the last thing here, you can also get help by clicking on the question mark at the top of the desktop. So let's go back to there. So I never do this, but yeah, so right here, this question mark, if we hover over there, it says View Product Documentation. So if you just click on that, it opens up an environment here that allows you to get lots of different help. And so MATLAB is the main thing. There are other things that I have access to that are various toolboxes that you might not have access to. So the main thing we would want is help on MATLAB. So we click on that, and now I want to know about syntax and data types. I can go there. I want to know about how to do various mathematics. I want to know about graphics. I want to know about how to do programming. I'd like to know about importing and exporting data and managing workspaces and files and so forth. Or I want to learn about how to build a graphical user interface, or how to convert my MATLAB code into C code, or what's the deal with the desktop environment. So you can click on that and find lots of stuff. So to be honest, really the best way to learn MATLAB is to just play with it. Like I said, I've been using this for 25 years. When I first started using it, there were no books, there were no courses. You bought MATLAB, you got a manual, but it didn't really tell you too much. But you just kind of got in there and started poking around with it and playing and figuring it out. Oh, and there, it wasn't really like the web. There was no Google, so you couldn't really Google this stuff. So you just kind of had to play, and I would encourage you to do it that way too. The more you play with it, the more you try, the more you ask, gee, what would this do? The better off you'll be in learning how to do MATLAB. So let's talk a little bit about managing our workspace. So I already showed you that as you create variables, you can look over at that current workspace sub-window and see a list of the variables there. And it will also give you some other information about it, like, how many elements there are in it, what its largest and smallest values are, and so forth. I showed you how to use clear. So if you just type clear at the command line, careful, it gets rid of all of your variables. So make sure you want to do that. If you only want to get rid of one, just type clear and then type whatever the variable name is. So if you remember, I created a variable named X. So I could just type clear space X, and that would just get rid of just X, none of the others. If I wanted to get rid of X and Y and leave the other two that I had after I think it was mynum and res, I could just type clear and then type X and Y and then hit enter. But I could put however many I want there. So that's ways of getting rid of a variable, and sometimes you want to clear it out because you don't want it. Now, suppose you've been doing a bunch of work, you've created a bunch of variables, and you'd like to save those variables for some other time. So we can save our workspace, and it's saved in what's called a mat file. So if you just type save and then whatever name you want here, so whatever it is, today's today's work, whatever you want. It will be saved, whatever you put in for F name, that will show up here, and it'll be .mat. And it's put into your current folder. So remember I showed you where you could navigate to different folders. So if you want to put it in some other folder, you better navigate there. Now you've saved it. Tomorrow you want to get that back. So you need to make sure that your current folder is the folder that holds the mat file that you want. And then you just say load fname. Now there is ways of putting a path, a folder path structure there as part of the name. And if you want to know about that, just type help load, and it will tell you about how to do that in a more general way. So we talked about workspace variables, and we showed how we could create them. So this is just don't worry about what this command is. It's some funny little thing that makes these things called magic matrices. I think they have things. I think the magic matrices are matrices whose sum along every row and every column is the same, if I remember right. I don't know. They're just fun little things. And this command rand, again, don't worry too much about that. I'm just using this as an example. That is one command that's used to create random numbers. So one thing, what we put here and what it does will depend upon what the command is expecting. But in this case, when you put a 4 there, it will create a 4 by 4 matrix. And for rand, when you put 3, 5, 2 there, it will create a 3 by 5 by 2 array. So how am I getting all this information here? Well, if you run the whos command, it gives a list. And actually these dots won't show up. That was just part of PowerPoint. And the whos command will give you a list of the names of the variables. Come on, there we go. It'll give you a list of the names of the variables. It'll tell you the size, meaning how many elements. So A will be a 4 by 4 matrix. B is a 3 by 5 by 2 array. It shows you how many bytes are being used to store this. And then we'll talk later about class, but you've probably already studied in your digital logic class and maybe a microprocessor class. You're studying about single precision floating point, double precision floating point, integers, and so forth. And that's what this class is. We'll talk more about that later. But the command whos gives you a quick way of kind of seeing what variables you have in your workspace. Of course, all of that is available up in that workspace window that we talked about. So yeah, the workspace window or workspace pane on the desktop, all that stuff shows up here in a little different format. But it also has some other stuff. It tells you the minimum and maximum value. So we just created that A matrix. The largest value in that A matrix is 16. And the smallest value in that A matrix is 1. And likewise, in this 3 by 5 by 2 array, here's the minimum and maximum values that are in there. So after you exit Matlab, if you haven't saved your workspace, it's gone. Okay, so just another plug here to do, save. And here we're just using an example of my file. You don't really need to put the .mat there. You could just put my file, or you could put the .mat there. And then later, as we just said, so this is a little bit of redundancy here in these slides, but if you wanted to load that later, you would just say load my file. You don't really need the .mat. So this should be enough to kind of get you up and running with Matlab. So hopefully you've got it installed on your computer one way or another, or have access to it somehow. And you can start it up and you can start playing around with it. You can't really do anything wrong. I will tell you a funny story. When I was a freshman in college, a long time ago, would have been September of 1979, so a long time ago, we didn't have personal computers, so to do programming you had to go to the computer terminal room, and you sat down at this terminal and you programmed. You would submit your program to run, and then you'd have to go over to the printout area and collect your results on printed paper. I had no experience using a computer at that point. I mean, none. I didn't even really know what it really meant to program a computer. So that was not only my first semester of college, but that was my very first class meeting. So like Monday morning, 9 a.m., and it happened that class had a lecture session and also a lab session. And it just so happened that my very first college class was the lab session. So there we are sitting in front of the terminal, and the professor says something like, well, if you type this in, it'll just blow up. And I'm thinking, like, really? Literally? I don't know what I'm doing here. So anyway, the point of the story is you really can't screw up inside Matlab. You can try it out. If you've done something wrong, it'll beep and it'll give you an error. You can always close the window and open it back up and start over again. And so, like I said, the more you play around with it and just say, what does this do? Or could I do this? Or how would I do that? And search through the help, or just Google. So you can Google, MATLAB sum of elements, and I bet it'll tell you that the command is called sum. And just play around with it, and you'll make good progress. But we've got other sets of notes coming up that will take you by the hand, step by step, through how to do some of these things. All right, we'll see you in the next video.